Okay, welcome back. In this module, we're going to be working in SPSS only, and looking at our ANOVA test and going over a few ways to run the ANOVA test. So first off, we need to select our cases, because if you'll recall, an ANOVA test, to be accurate and not violate one of the assumptions, we need to have about equal cell size. That means we need about equal participants in each group. So we want to select only certain countries so we can run an ANOVA on them and find out if we have differences among levels of the acceptance of political violence between those countries. So we want to select this countries, and I actually have it already typed in. You want to select this. So if the country is Canada, or country equals United Kingdom, or country equals Australia. After you've go ahead and got that typed in, you just click OK. We'll go OK, and there's our filter document letting us know it worked. If we go back in here, a lot of the items are crossed off. So there are actually a few ways to run a one-way ANOVA. You probably recall seeing this item right here, and that is, yes, one way to run one-way ANOVA. And you'll have a screen that looks like this. We'll want to put political violence over here, but you'll notice that the country field is no longer there. We have a field here, but that's actually the filter itself that's being used. So we actually don't have a country field. That's because, similar to running the chi-square test that we did last week, we need to have a numeric representation of country to have it show up in this way. But we're not going to mess with that, because there's another way that you don't need to do this. And I actually recommend using the other way because it's a little bit more useful for different ways of doing things. So we're not going to worry about this way. The output will look very similar if you were to run a test this way. I just wanted you to be aware that this is one way to run a one-way ANOVA. You would like move a factor over here. We're not going to do this, but such as though you can change your options, add any post hoc tests that you may want, but we're not going to worry about that in this box. So what we are going to look at is another way, which is going to the analyze general linear model and then univariate. And this gets us another way to run an ANOVA item, or one-way ANOVA. So let's just move political violence over the dependent variable, and country over to the fixed factors item. So this in this item, now we can see only our countries are going to be used in that item. So we can go to options, and we can show interaction effects and means for interaction effects if we were to have any, or factors. Let's just show the means for country over here, and we'll display descriptives, effect size of verbs, observed power, homogeneity test. That's really useful. That's testing the homoscedasticity. We don't need a residual plot. That was something else I was looking at. So having these four things checked are pretty useful, and we can change the significance value of our test if we want to change to 0.25 to make it a more stringent test, or a little bit lighter if we don't. We can also go to post hoc. This is kind of a useful thing. A post hoc, a ANOVA test is a test that will tell you that there is a difference, but it's not a test that will tell you where a difference is. So to do that, we have a thing called post hoc tests, which run different tests to see where the difference occurs in a test. To do that, you just move it over to the other box. Then you can select what test you want. The LSD test is a pretty standard. It's a moderate test. There's also SNK is a more easy test to get past, to find differences, and Chaffee is more stringent. Those are the three that are really used in my area. You may have other tests that are used in your area that you may want to look at, but the LSD is a pretty moderate, good to go test that you can get. You know, it's not too strict, not too easy to get significance. So the LSD is a pretty good one. So we'll just click OK. And that looks good. We can plot it if we want, but we don't really need to do that for in this case. We'll just click OK. So you can see it gives us our means, our total mean, and the mean for each item. As you'll recall, those are the same as what occurred in Excel that we saw. Here's again Levine's test for equality of error variances. So the null is that the error variance is the same across groups. So the variance is equal. To have that, this is a test of the homoscedasticity assumption, and if it is significant, we have violated the assumption. As you can see, it is not a significant test, a significant result, so we're okay in this case. The variants are equal across groups. So then we get actually down into the results. And this may seem like a kind of a scary test, but if you look, you'll see a lot of the things that we calculated before. In the corrected total, in the sum of squares box, you can see that is the sum of squares that we calculated in Excel. And in the error area, you'll see that is the sum of squares within subjects that we calculated in Excel. And at the country item, that's the sum of squares between subjects that we calculated. You can also see the degrees of freedom between and within that we calculated in Excel are exactly the same. And the F test that we calculated in Excel is exactly the same. And just as I said, it is not significant. So if you're just looking at this and you want to find out whether your IV is whether your group category is a significant, if there's a significant difference among the group, you just need to look at this box, find your label or your variable name, go over to the F and the significance, and those are going to be your scores. The partial eta squared is the level of difference. So that's kind of like the F test is kind of a weird thing. It doesn't really tell you in real life how big the difference is. It just tells you that compared to some statistical distribution, these groups have different means. But the partial eta squared gives you an actual kind of a level that you can see how big that difference is. In this case, it is not very big because we have a not significant difference. And the observed power, that gives kind of an idea of the power of your statistics. So you want that to be larger for it to be more significant. Here we can see the means again, standard errors that are associated with the means, and the confidence interval about the mean for the different items. Then here we get into the post hoc tests. So this kind of how this particular the output for each post hoc test is different, but in this case, the LSD test, it looks at each country individually, and then each IV group individually, then all of the groups within each group, and then it will show you over here where the significant differences lie between the groups. So Australia compared to Canada is a non-significant difference. Australia compared to the UK is a non-significant difference. This is completely what we would expect based off of our non-significant f value. But if it was significant, this test would tell you where the differences lie between the groups. So that's really useful for your actual more understanding of the phenomenon you're examining. One other thing I want to talk about is if this was significant. You may have noticed that there was a special box for that. If we go back here and we go into the post hoc test, there's a special box that you can look at that if equal variances are not assumed, and then there's specific tests that you can run. So that is how you would potentially deal with that. Like, we'll just run this one really quickly. And this will give you, if we scroll down to where the test is, this will give you where any differences may lie with an adjustment for violation of the homoscedasticity assumption. So that's good to know, and this reads just the same way as an LSD test. So that'll be a good thing to have in your pocket if you violate the assumption of homoscedasticity. You probably, violating that assumption would probably throw your F statistic in general into a question that whether that was actually significant or not, but you can back it up with a Dunnett T3 test that does not rely on equal variance, and you can see if there are actually differences based on this score. So it's a good thing to have, a good thing to know that's there. So that's it for the ANOVA tests and SPSS for the one-way ANOVA, the univariate ANOVA. We're going to be going over different ANOVA tests in the next class session. So I will see you then.